There is a business district in Shenzhen packed with glass towers, dozens of buildings, offices, shops, hotels, thousands of people moving through them every single day in the brutal heat of a southern China summer. Look closely at the outside of any of those buildings. You will not find what you expect. No window units. No compressor boxes clinging to the walls. None of the metal cages full of humming machinery that cover the outside of nearly every building on the planet. And yet step inside. The air is cold. Properly, comfortably cold. So if nothing on the outside of these buildings is making cold air, where exactly is it coming from? The answer to that question is not one thing. It is 6 things. 6 completely different systems operating simultaneously at every scale. From the clouds above the city, all the way down to a chip the size of a coin pressed against someone's neck. And understanding how China built all 6 of them starts with understanding what happened in the summer of 2022. Because that was the moment it became clear that a slightly better air conditioner was never going to be enough. The summer of 2022 was unlike anything in China's recorded history. A heat wave that dragged on for more than 2 months. Temperature records shattered that had held since national weather monitoring began in 1961. The Yangtze River, one of the longest rivers on Earth, thinned out so badly that dry, cracked riverbed became visible in places where boats used to pass. Hydroelectric stations across Sichuan, which normally send electricity to cities over 1,000 kilometers away, saw their output crash. Not enough flowing water to spin the turbines. Entire factories were told to close, not from a labor dispute, because there was not enough electricity left to run production lines and keep homes livable at the same time. Here is the detail that makes this a systems problem and not just a weather problem. Air conditioners run on electricity. A severe heat wave cripples electricity supply, which means the hotter it gets, the harder the grid gets pushed, and the closer the whole system comes to failing at the exact moment people need it most. You cannot solve that problem by adding more air conditioners to the grid. Every unit you add makes the underlying problem worse. So engineers went looking for ways to pull heat out of the equation altogether. And the first place they looked was the least likely place imaginable: the clouds themselves. Most people will never hear this part of the story, but during the 2022 crisis, Chinese authorities turned to a tactic that would sound completely made up if it were not fully documented on state television. They set out to manufacture rain over an area roughly the size of a small country. China operates the largest cloud seeding program on Earth. The method uses silver iodide, a compound whose crystal structure mimics ice closely enough to trick water vapor into gathering around it and freezing. Once enough ice crystals cluster together, gravity takes over and they fall as rain, coaxing precipitation out of clouds that might otherwise have drifted past a parched city without releasing a single drop. Delivering the chemical is where it gets dramatic. Rocket launchers, anti-aircraft weapons repurposed to fire slim canisters skyward, manned aircraft threading through storm layers, and during the worst of 2022, military-style drones staying airborne for hours over Sichuan, releasing dozens of silver iodide charges across thousands of square kilometers of sky. Within days, some areas that had been rationing water were dealing with the opposite problem. Here is the honest part, though, and this is important. Cloud seeding cannot summon storms out of clear sky. It cannot dramatically outperform whatever moisture already exists up there. What it can do is nudge a reluctant cloud into releasing water it was already carrying. And when it works, it does double duty. It knocks down the air temperature immediately, and it refills the reservoirs that the rest of the country's power and water systems depend on. So China started at the top, literally in the atmosphere. But the next layer of this system did not come from a drone command center. It came from a building technique that engineers figured out roughly 1,000 years before anyone had a word for climate control. And what they rediscovered will change how you think about the building you are sitting in right now. Before electricity existed, people in parts of China were already living comfortably through summers, just as brutal as today's. Inside homes with no fans, no vents, and no mechanical parts whatsoever. Step inside one of the old courtyard homes still standing in the Huizhou region, and something unusual sits at the heart of the structure. Not a hallway, a gap. A tall, narrow shaft cuts straight through the center of the house, open to the sky above. It is called a tianjing, a sky well. It looks decorative, but it turns the entire house into a passive cooling system, using nothing but temperature difference and gravity. Warm air always rises. The rooms surrounding that central shaft sit low and shaded, protected from direct sunlight, which keeps the air pooling near the floor cool and dense. Meanwhile, heat building up elsewhere in the house drifts upward and slips out through the opening at the top, pulling fresher, cooler air up from the rooms below to replace it. Interior readings inside surviving Skywell homes show the air staying noticeably cooler than outside on a hot afternoon, sometimes by several degrees. No electricity, no refrigerant, no moving parts, just physics. What turns this from history into the future is what engineers realized next. The courtyard itself was never the essential part. The moving column of air was. In Guangdong, a 68-story tower now uses internal vertical shafts to channel air, borrowing the Skywell's basic trick without needing an open courtyard at all. A 1,000-year-old solution scaled into a modern skyscraper. Old solutions were not primitive. They simply solved problems that later generations outsourced entirely to machinery. And one of the biggest problems modern cities never properly solved is sitting directly under everyone's feet. That dark pavement under your feet is doing more damage to your comfort than almost anything else in a city. Standard black asphalt reflects only 5 to 10% of the sunlight that lands on it. Nearly all the rest gets absorbed directly into the material. By mid-afternoon on a scorching day, that surface can climb past 60 degrees Celsius, hot enough to burn skin on contact. And unlike a rooftop, a road stores that heat and releases it slowly well into the evening. A big reason a city can feel hotter at midnight than the fields just outside its edge. Researchers call this the urban heat island effect, and roads are one of its biggest contributors. Here is what most people never hear about what China decided to do about it. Cities including Guangzhou and Shenzhen tackled it head-on by repaving major roads with cool pavements. Reflective coatings that bounce sunlight back skyward instead of absorbing it. Layers that slow how quickly heat travels into the material. Porous surfaces that hold moisture so heat can escape through evaporation. The same principle behind the fine mist you sometimes see drifting over a crowded sidewalk. A spray so light the droplets vanish before touching the ground, dropping street-level temperatures by 5 to 8 degrees Celsius, using barely any electricity at all. Testing on these reflective coatings has shown surface temperature drops of 7 to 14 degrees Celsius compared to plain asphalt under identical sun exposure. Apply that across an entire road network and you are lowering the baseline temperature of the whole urban area, right when it matters most, after dark, when the city should be cooling down but usually is not. So we have cloud seeding working at the atmosphere level, a 1,000-year-old airflow trick working at the building level, reflective coatings working at the street level. But here is where the story takes a turn that most people find genuinely hard to believe the first time they hear it. The next layer uses outer space as a heat dump. Roll a specific coating onto a roof and the building underneath becomes cooler. With no wiring, no power draw, and no moving components anywhere. Even sitting directly under harsh midday sun. Zero energy input. The building gets colder. That sounds like it should be physically impossible. It is not. But the explanation requires understanding something about heat that most people were never taught in school. The science is called passive radiative cooling. It pulls off two separate tricks simultaneously. First, the surface bounces back nearly all the sunlight striking it, so the building barely absorbs any solar energy to begin with. But the second mechanism is what makes this genuinely remarkable. Every object with warmth releases some of that heat as infrared radiation. Ordinarily, that radiated warmth bounces between nearby surfaces and gets reabsorbed almost immediately. The heat stays local. But there is a narrow slice of the infrared spectrum that Earth's atmosphere lets pass through freely, almost like a window straight out of the planet. Heat radiated at that exact wavelength skips past the atmosphere entirely and escapes into deep space. a place sitting only a few degrees above absolute zero. This coating is tuned to release its heat precisely within that escape window. It turns empty space itself into a bottomless heat sink, one that never sends a bill and never runs out of capacity. Because the surface loses warmth faster than sunlight can replace it, the coated material ends up cooler than the surrounding air, even in direct light. A research group in Hong Kong turned this into a commercial product. Rooftops treated in direct sunlight have shown indoor temperature drops of roughly 10 degrees Celsius, and cooling energy reductions approaching 40%. Read that again. 40% less cooling energy from a coat of paint, using deep space as the mechanism. While the rest of the world is still arguing about which refrigerant to use in the next generation of air conditioners, China has a coating that dumps heat directly into the universe and calls it a roofing product. But a coating on a roof and reflective paint on a road still leave one massive unsolved problem. What about the buildings themselves? The dozens of towers in a single business district, each running its own fleet of air conditioning units, each duplicating the exact same fight against the exact same heat, over and over across an entire skyline. That is the problem nobody had seriously tried to solve at city scale. Until Shenzhen did. Planners asked a question that sounds almost embarrassingly obvious once you hear it. Instead of thousands of small, inefficient machines each fighting alone, why not build one massive, highly optimized system to serve everyone at once? The concept is called district cooling, and in the Qianhai zone of Shenzhen, it operates on a scale that is hard to visualize. Several floors underground sits a facility that a visiting reporter once compared not to a piece of equipment, but to an entire factory floor. Packed wall to wall with pumps, pipework, and chillers across an area roughly the footprint of a football field. Its sole purpose is producing chilled water at industrial volume, then sending it through insulated underground piping into building after building throughout the district. Each tower connects into that network the same way a home connects to the municipal water supply. Cold water arrives, absorbs heat from inside the building, makes the return trip so the plant can chill it again. One shared, extremely efficient cold source standing in for what would otherwise be thousands of scattered wasteful ones. The Qianhai facility covers roughly 3 square kilometers of buildings, and it reportedly saves close to 130 million kilowatt-hours of electricity annually, comparable to leaving 16,000 tons of coal unburned and keeping roughly 130,000 tons of CO2 out of the atmosphere every single year. That is the literal answer to how an entire district stays cold, without a single traditional air conditioner visible on the outside of any building. The machine is underground. Nobody sees it. Nobody hears it. The cold just arrives. But here is the thing that system cannot do. And this is the gap that the final layer of China's approach is designed to close. Everything covered so far cools a space. A room, a building, a district, a city block. None of it helps the one person this whole system ultimately exists to protect. Somebody standing outside with nowhere to hide from the sun, waiting for a bus, walking down a sidewalk with nothing overhead but open sky. A delivery worker, a construction crew, a child walking home from school through streets that are 14 degrees hotter than the surrounding fields because of the asphalt under their feet. Conventional wisdom says you cannot cool open air at meaningful scale. China decided to test that assumption anyway. At bus shelters, subway entrances, and busy plazas across multiple cities, freestanding cooling units now push streams of chilled air directly into public space, meeting people where they already are, rather than asking them to go somewhere cooler. Many of these units run entirely on solar power. The logic is almost too clean. The hottest hours of the day are also the hours when solar panels generate the most electricity. So the same sunlight causing the discomfort ends up powering the fix. But even a public cooling station requires you to stand in one spot. It cannot follow you. And in a country where enormous amounts of daily life happen outdoors, where millions of people spend hours each day working and moving through heat that would shut down most Western cities, a stationary solution is only part of the answer. The part that is now touching the most lives every day is the smallest one. And most people watching this video have probably never heard of it. A curved band worn around the neck. resembling headphones at a glance, quietly directing airflow across bare skin while you move through the world. A handheld fan fitted with a tiny water reservoir releasing a fine mist into its airstream. Vests and jackets stitched with battery-driven fans pushing a continuous current of air across the body. Wearable coolers have moved from niche gadget to daily habit for enormous numbers of people in a remarkably short window of time. The neck-worn versions stand out most. The better models press a compact metal plate against the back of the neck, powered by a solid-state cooling chip underneath. Here is what that chip actually does. When current flows through it, one face turns genuinely cold. Not slightly cool, cold. Cold enough to draw heat straight out through the skin, located right above one of the body's major surface blood vessels, helping bring down core temperature more broadly, not just cool the skin at the contact point. This is the detail that changes how you think about these devices. They are not just making you feel better, they are helping regulate the body's actual core temperature by targeting the specific location where doing so is most physiologically effective. Heat stroke remains a genuine killer every summer in China and across much of Asia. In 2022 alone, the same summer that forced factories to close and rivers to shrink, heat-related illness hospitalizations spiked dramatically in multiple provinces. An affordable cooling device that ordinary people can keep on hand and flip on the instant conditions turn dangerous is closer to a safety tool than a consumer product. The buried plant underground keeps the district livable. The chip against someone's neck keeps the individual alive. Now step back and look at all 6 layers together, because this is where the full picture becomes genuinely hard to argue with. At the atmosphere level, drones and rocket-launched canisters nudge clouds into releasing rain over parched cities, knocking down air temperature and refilling the reservoirs that power everything below. At the rooftop level, a coating quietly discharges building heat directly into deep space around the clock, cutting cooling energy consumption by up to 40% with 0 moving parts and 0 electricity required. At the street level, resurfaced roads with reflective coatings absorb dramatically less solar energy, lowering the baseline temperature of entire urban areas, especially after dark, when cities should be cooling down, but historically have not. At the architectural level, a 1,000-year-old airflow trick originally built into courtyard homes, with no mechanical components, has been scaled into the vertical shafts of 68-story towers, moving air through buildings the same way gravity and temperature difference moved it through farmhouses a millennium ago. At the district level, a single industrial facility the size of a football field, buried several stories underground, replaces thousands of individual air conditioning machines through a hidden network of insulated pipes, saving 130 million kilowatt-hours of electricity every year from one installation alone. And at the personal level, a solid-state cooling chip pressed against the back of someone's neck draws heat out through the skin above a major blood vessel, helping maintain safe core body temperature for workers, commuters, and anyone else moving through heat that no building system can reach them in. Combine every one of those layers and you get something no single air conditioning unit, no matter how advanced, could ever produce on its own. A city that keeps functioning through heat extreme enough to otherwise threaten its power grid and the people living on it. Here is what makes this story bigger than China. Most places on Earth still treat heat as something private, a problem solved room by room with a machine mounted on a wall, each household fighting the same battle with the same device, with no coordination between them. China began treating heat as shared infrastructure, something to be engineered deliberately across an entire city the way roads or water systems are engineered, stretching from the sky above down to a device someone slips around their neck on the way out the door. Heat waves are growing longer and more severe on every continent. The summers ahead will be hotter than the ones we just had, and the approach that kept an entire business district cold without a single visible air conditioner, that approach is too logical, too layered, and too effective to stay inside one country's borders for long. The question worth sitting with is this. Out of everything in this video, the hidden underground plant nobody notices, the coating that releases heat into orbit, or the small chip worn around someone's neck? Which one do you actually want in your city first? Drop your answer in the comments. And if this changed how you see the sidewalk under your feet or the roof above your head, hit like and subscribe. Because the systems being built to keep cities livable through the heat that is coming are worth understanding before you need them.